So this video is about something that's pretty important, and it's the overvoltage relay. So it's a simple relay, has one coil in it and two contacts, and the coil is calibrated to energize somewhere between 32 and 33 volts. It's a very important relay. If you've ever had to write a big check for avionics repairs or radio repairs, you can appreciate the value of having voltage that's not out of control going to those components. And that's the purpose of the overvoltage relay. As you can imagine, when the voltage gets up between 32 and 33 volts, it activates the relay, and it comes up and it works very closely with the field control relay. The field control relay is operated by these pins through this Cannon plug. And it has two positions. Most relays, when you energize them and de-energize them, they revert back to their original position. But this is different. It's kind of flip-flops from position A to position B, and then it stays there. So the normal position allows the generator charging system on the plane to operate normally. And the abnormal position is triggered by the overvoltage relay. So the field control relay does three things simultaneously. It de-energizes the coil on the generator itself, the field coil. It turns it off and shuts down the output of the generator, which is a good thing. It also comes over and it turns off the switch wire on the reverse current relay and completely isolates the generator from the bus or the batteries. And lastly, it disconnects the coil inside of the voltage regulator so that the voltage regulator is totally taken out of, it's isolated from the rest of the plane. Remember that many airplanes have multiple engines, and each engine has its own generator control system, just like you see here. And they talk to each other because they're all sharing the load of keeping the bus battery voltage charged up. So the field control relay does all of that, and it's a pretty complicated device on the inside. I'll show you a schematic of it. So this is the inside of what one looks like in schematic form. It has 10 sets of contacts inside there. Some of the contacts are in a closed position normally. These are all closed. Here's an open one, another open one, another open one, closed, 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 open. And you can see on the drawing there's a coil here and a coil down here. And those two coils, when energized, flip it from the normal position to the overvoltage position. The normal position comes down here, and it's connected directly through pin B to the reset switch that's up in the cockpit of the plane. It's the generator on switch, and there's a spring-loaded option. If you move the switch to the down position, it momentarily resets this back to the normal position. The coil that's up here goes to pin G, as in George, is tripped by the overvoltage relay. So an overvoltage condition coming from the overvoltage relay will take all of the contacts that are shown now as normally closed and open them, and all of the contacts that are normally open in this drawing then become closed. So the two items work hand in hand together, and they're there. The whole purpose of this thing is to protect the airplane from an overvoltage situation. If the overvoltage relay on the charging system activates in flight, it will flip the field control relay into the overvoltage position. And there's two ways to reset it. One, you have to climb all the way in the back of the plane and snap this button in, as I'm doing here. However, up in the cockpit of the plane, it's more convenient to come down to the generator switch. Give you a better view here. So this would be the on setting, the off setting, and here's the reset. So this will flip the field control relay back into its normal mode. It's possible that that reset will take care of the problem. If not, if it keeps tripping, what you want to do is just turn it off until you get back on the ground. You'll have other engines charging the batteries to get you back in safe flight. So we're going to run a overvoltage test to make sure the overvoltage system is working on our test stand. What we're going to do in this video is take the cap, the protective cap off the voltage adjustment screw on the regulator. And as the engine's running, we're going to turn the screw in and we'll watch the voltage rise. And somewhere around 32 or 33 volts, the voltmeter will drop to 0 and the generator failure light will come on. That proves that the overvoltage relay sensed the overvoltage. It did its job. It came up and told the field control relay to flip, which in turn stopped the voltage output of the generator and isolated it from the batteries. On our test stand, we put in two LED lights. One is labeled overvoltage and the other is labeled normal. Those two lights would indicate the position, the flip-flop position that the field control relay is in. So we'll run the engine at a medium throttle. You won't be able to hear me. And in addition to the analog voltmeter, we'll have a digital voltmeter set up and operating. And we'll be able to determine what voltage the overvoltage relay tripped at. So we'll start up our engine.